Okay, so now we're going to talk about trapezoids. The general properties of trapezoids are fairly easy to understand if you've got a basic knowledge of what a trapezoid is. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, so the one pair of parallel sides. And so this pair of parallel sides gives us a trapezoid. Okay, so BC is parallel to AD. BC and AD are called the bases. Okay, so the parallel sides are called bases. Okay, so this is a base and this is a base. Okay, now the other two sides and I'll call them non-parallel are called legs. And so when I label these, this is a leg and this is a leg. So AB and CD are legs. There's one other piece we need to talk about here. If the legs are congruent, the trapezoid is called isosceles. Okay, so if the legs are congruent, the trapezoid is called isosceles. Okay, also, these are called base angles because they're the angles that are connected to the base. And these are called base angles. If we talk about base angles, and we talk about isosceles trapezoid, if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So, because this is an isosceles trapezoid, it has two congruent legs, then we can say angle B is congruent to angle C, and angle A is congruent to angle D. So isosceles trapezoid is just like an isosceles triangle. The legs are congruent, so the base angles must be congruent. Okay? If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So when we see something like this, where angle A is congruent to angle D, we could say ABCD is isosceles. Okay? The last part. A trapezoid is isosceles if and only if its diagonals are congruent. So, if AC is congruent to BD, we do the double-headed arrow because it's a biconditional. It's two conditions. So, if AC is congruent to BD, then ABCD is isosceles. But if ABCD is isosceles, then the diagonals are congruent. It works both ways. Okay? So let's fulfill that second objective. Let's use the properties of isosceles trapezoids to find some measures and to solve some problems. We're going to find the measure of angle y. It's important that in an isosceles triangle, an isosceles trapezoid, or if we're talking about any kind of trapezoid, we understand that two of the sides are parallel, which gives us a lot of things that we already know how to do. Because if they're parallel, then we have things like alternate interior angles, alternate exterior angles, we have same side interior angles, and consecutive angles. Well, we know that if these two lines are parallel, then the measure of angle x plus the measure of angle W is equal to 180. Well, what we'll do is we'll substitute, because the measure of angle X we don't know, but we have 117 here. And so when we solve for this, we end up with something that will give us the measure of actually two angles that we want. Whoops. Let's do a redo on that. Okay, so the measure of angle X is equal to, and this is going to be 63 degrees. And so this is 63. We don't necessarily want X, but we know that because this is isosceles, that this angle X is congruent to angle Y, so the measure of angle X is congruent to the measure of angle Y. The measure of angle Y is 63 degrees. Okay, so we used another base angle to solve for the measure of that angle. Let's think about RT. We have a couple of pieces of information, and this is stuff that I'm giving you. So RT is 24.1. Okay, QP is equal to 9.6. We want to find PS. Okay, that's information that was given. So what I just wrote in was already given. You should write that down as stuff that's already there. Okay, so RT is going to be 24.1. So we know that RT is congruent to QS, right? Because QS and RT are the diagonals of an isosceles trapezoid. So they are congruent. Well, this means for us that 24.1 is equal to QS. Well, QS is really equal to QP plus PS. Okay? Because QS is a segment, so we use the segment addition postulate. So 24.1 is equal to QP plus PS. Well, 24.1 is 9.6 plus PS. When we subtract 9.6 from both sides, we end up with PS equals 14.5. Okay, so that's how this works. We did those two. I would like for you to find the second two. Okay, now I'm going to write in some additional information here. We need to find the measure of angle F. Well, the measure of angle F we're going to find knowing that this is 49 degrees. And we're given information here that JN is 10.6, NL is 14.8. I want you to find KM. Okay? You try those two. We will talk about those two in class. Okay? Now, I'm going to move down. Here's another example. When we talk about this example, we have two base angles here that are congruent. And so what we are going to do is we are going to say, this is an isosceles trapezoid. How do we know? Okay? Now, we know that this is an isosceles trapezoid because they just told us that this is an isosceles trapezoid. So we know that base angles are congruent. Okay? So we're going to set these two equal to one another. So 2y squared minus 25 is equal to y squared plus 24. Okay? Base angles are congruent. So I'm going to add 25 here. I have 2y squared is equal to y squared plus 49. I'll subtract y squared. I have y squared is equal to 49. So y is 7 or negative 7. Okay? So that's how this works. I would like for you to try the next one. Okay? I want you to try this next one. We will talk about it in class. Okay? I will give you a hint. You're going to use the properties of the diagonals of a trapezoid to find the answer to this problem.